In this video, we will be seeing on one of the most important derivations of the unit, that is piezoelectric transducers. We know what is a piezoelectric transducer. So it converts mechanical vibrations into electric voltage. So when a mechanical pressure, force, vibration is applied on one axis, you will get an equivalent electrical voltage across the required axis. So this phenomenon is called piezoelectric effect. And so let's see the construction of piezoelectric crystal. So this is a piezoelectric crystal. Force is applied, and the application of the force will generate voltage across this, and it can the piezoelectric crystal can be oriented along any of the three axes or all the three axes to measure forces in the specific axis. So the magnitude and polarity of the induced surface charges are proportional to the magnitude and direction of the applied force. Okay, so the charge q is given by d into f coulomb. So charge is directly proportional to the force, and it has d. So d is what? Q by f, that is charge sensitivity, which is coulomb per newton. So what is the change in charge per newton of force applied? So this is charge sensitivity, and f is the applied force. Okay, so we know the Young's modulus. So what is Young's modulus? It is equal to stress by strain. So the stress is given by force by area, that is F by A. Okay, so so Young's modulus can be given by this equation, where E is the Young's modulus, and how this equation is formed, you can see that F will go downside, that will be F by A, that is stress, and delta T by delta T will also go down, that is strain. So taking all to one side, you will get this equation AE by T into delta T when the force causes changes in the thickness of the crystal. So A is the area of the crystal, in m squared, meter squared is the unit, thickness of the crystal T in meters, E is the Young's modulus, Newton per meter squared. So we can write the same equation like this. So Ft by A into del T, Newton per meter squared. So you take all this to the other side, you will get this equation. Okay, so area can be written as width into width of the crystal into length of the crystal. Okay, then you substitute 2.63 and 2.64. We have the charge, so we have that we have f, and you substitute the value of f in the q equal to df. So you will get an equation like this. So once you get the equation like this, you save this equation. Charge at the electrode gives rise to an output voltage, right? So the output voltage is given by q by c, where c is the capacitance between the electrode, q is the charge. Okay, and capacitance, you all know that it can be written as epsilon r epsilon naught a by t. So substitute this in the equation 25.67. You will be getting an equation like dt epsilon r epsilon 0 f by a. So f by a is the pressure, T is the thickness, and d by epsilon naught becomes a constant called voltage sensitivity G. Okay, which is a combination of d divided by epsilon or epsilon naught. Okay, so what is d here? D is the charge sensitivity. Okay, so now you know what is G. So G is the voltage sensitivity of the crystal, and constant for a given crystal, and G can be written further as epsilon naught by T into P. So how do you arrive at this equation? So here you see, right, you take T and P to the other side, that becomes T by P, E epsilon not T by P, that is equal. Then you take T up to the numerator, epsilon naught by T becomes the electric field strength given in the by V by M. P is pressure, that is F by A. So you how do you get this dimension of Vm by N? So you have pressure is force by area, that is Newton per meter squared, while this is what V by M. Okay, you substitute these two, you will result in Vm by N. Okay, and G is defined as electric field strength divided by stress. Okay, and charge sensitivity is further expressed by epsilon naught into G. So charge sensitivity and G are related in terms of the constants permittivity, and these are some values of the permittivity that you need to remember for solving problems during examinations. Okay, and usually the problems in this kind of area comes as 33, 23, like the subscripts. What do they mean? Direction in a specific axis, the field produced in direction 3, and direction, that's third direction is z axis, then the field produced in the 3 and stress applied in that direction is given by E0 by T by F by A. Okay, so and then you reorganize, you will get G33 by TP. Similarly for the charge density. Okay, and thickness is the thickness here is parallel to the crystal, and force along the another axis of the crystal, and expansion, this is a tensile, and another one is transverse expansion. Okay, so these are some of the modes of operation of piezoelectric crystal which you should remember for your examination purposes. Okay, then let's go to the one of the important problems. So here if you see a barium titanate pickup as a dimension of these values, force acting on it is 5 newtons, charge sensitivity they have given, permittivity they have given. If the but here they have given, but in the examination if they don't give, you should be in a position to write. If the modulus of elasticity of barium titanate is 12 into 10 power 6 newton meter squared, calculate the strain, calculate the charge and the capacitance. Okay, so because charge and the capacitance are the equivalence that is required for you to design your amplification circuits. So area of the plates A equal to W into L, which is given by 25 into 10 power minus 6 meters squared. Pressure, the force by area, you will result in 0.2 mega Newton per meter squared. And what is voltage? D by epsilon 0 epsilon r. So the epsilon permittivity complete is given as 12.5. Substitute it, you will design in the voltage sensitivity, then use the voltage sensitivity pressure thickness values to find the voltage generated, and then find the strain from the Young's modulus equation. So stress by Young's modulus, so you know Young's modulus, stress is given here, and you will result in 0.0167 meter per meter. Then what is your charge? So charge is given by D into F. D is the charge sensitivity that they have given. Substitute it, you will result in picocoulombs. What is the capacitance? You have determined the charge, you know the output voltage, then substitute it, you will find what is the picofarad. So okay, this is one of the important problem that that most of the time will be asked in your examinations. Thank you.